It was good as busy.
Make sure you guys found your new seat before you sit down. Blake.
I stopped at went to the like hang out with one of my teachers that I like so I did that.
Okay, I guess we're not doing Minute of Silence today, I'm not sure. But yesterday I did not have to give the PSAT, so that gave me some time to do a new seating chart just to kind of freshen things up a little bit. I do like to try to keep people together that I think work well together, so if you like your table partners, then just make sure that you're staying on task, quiet at the start of class, all the stuff that I ask of you guys. But also, we had a couple extra tables, and so I wanted to get those out just to make it a little bit easier to get around the room. So, okay, this morning I've got one new thing to show you from this unit. It is a really small thing that's going to take about 30 seconds, but that would be the derivative of exponential functions. So if you would please number that as 43. Then after we go over that real quickly, we're going to split in two different directions. Those of you that have questions, oh, never mind, I'm sorry. That will be near the end of class. I've got one Khan Academy assignment assigned to you. It is on related rates, but specifically Pythagorean theorem type. And my 8A did those pretty quickly. It was just one of them, so shouldn't spend too long on that. And then the other two handouts you guys picked up, I'm trying to give you the test review a little bit early again. Those 2 pages make up 45, the test review, and the answers to that is on the back page. So hopefully you can get through a big chunk of that today. But I guess it doesn't have to be finished yet. We don't have our test next class. Okay, so the derivative of exponential functions. This is what your textbook would say at the top. And I like to connect it to the derivative of e to the x because it's almost the same thing you've been doing. There's just one part that I haven't really told you yet. But when I tell you that part, you can apply it to other exponential functions. So an exponential function is where you have a number to a variable, and the variable is in the exponent. So for already probably the 100th time this year, the derivative of e to the x is going to be e to the x. But the part I didn't tell you is this part. It's technically also times the natural log of the base, which is e. But what is the natural log of e?
1.
And because multiplying by 1 doesn't change anything, that's why we haven't been talking about that. But if you can remember that it's really there, then 3 to the x is just going to be 3 to the x times natural log of 3. Natural log of 3 doesn't simplify to 1, so we need the whole thing. 7 to the x would be 7 to the x times natural log of 7. Just like e to the x has an e to the x, 3 to the x has a 3 to the x, 7 to the x has a 7 to the x. But you have to include this natural log of the base. And of course, chain rule sometimes applies. So if you have 8 to some power, it's going to be 8 to that power times the natural log of 8. And you still have to consider chain rule. So the derivative of x squared would be 2x. 5 to the 2x would be 5 to the 2x times the natural log of the base. And because of chain rule, this one would still need to be multiplied by 2. Okay, this one I'd like you to try to write down what you think before I tell you, just to see if it clicked or not. So like any exponential function, e to the x, 7 to the x, 8 to the x squared, you're going to need all of that stuff. So you need a 10 to the x cubed plus 5x minus 1. You also needed what?
Natural log of 10.
Okay, natural log of 10. Now,
The derivative of the x.
yes, but does this simplify to 1? Good. Be careful. Natural log of e is 1, and log base 10 of 10 is 1, but natural log of 10 is not 1. Okay, and then just worry about chain rule. Chain rule would be an extra 3x squared plus 5. All of that would be his derivative. So really messy looking derivative, but not terribly difficult. But you do need to memorize this one. This is one we didn't ask you to memorize in Unit 2, but our upcoming test has 1 or 2 of these questions. So I would say, if anything, people may miss it on the test just because this isn't one that you have to practice 100 of to understand, but obviously reviewing it real quickly for a minute or 2 would be in your best interest. Now, there is 1 or 2 of these on the test review too, but any clarifying questions about this handout before we put it aside? Okay. Again, I really think try to memorize this example, because then that will help you do all of the rest. Of course, you still have to think about chain rule. Oliver, you're right there. We got new seats. Okay, so no questions about that one? Okay, the next thing I'd like you to do is the Khan Academy. So if you guys would get that out. And as I've been saying, related rates are just harder and they take more practice. But the fact that you know all of these are Pythagorean theorem types, I think simplifies it quite a bit. Not right now, but if I change my mind, I'll come to you.
Get delivered like closer to Christmas. Oh. My Chromebook has been recorded still.
Your Chromebook has?
Yeah.
Is that your Chromebook?
Yes.
Should I take it up to the tech office?
I don't know. You can go try, or you can just do this on your phone. It's up to you. You'll need to go to the tech office at some point, but
Do you mind if I just go on? I'll do this.
I just don't know if they're going to be down there right now.
Yeah.
They probably don't expect to. Okay, so our plan here is finish up the Khan Academy. If you need to try it a bunch of times, then that's fine. But again, my 8A classes, it went pretty smoothly. I think about half the class got the first 4 right, and half the class had to do it the second or third time. But definitely possible to do it in one go. Obviously, once you finish this, go ahead and start tackling number 45. Once I've seen everybody has moved on to 45, I will interrupt you and give you guys a chance to ask questions from that 41. Because that 41, this will be the 3rd class that we look at that one, so I want to be finished with it. So if there's some of those you need help with, you will need to ask here in just a bit. There are some other related rate Khan Academies that we probably won't get to, but of course you're encouraged to go and find those and practice them if you think you need to practice them. I picked this one over the others because the Pythagorean theorem type is the most common type on our AP exam. So I would be surprised if your next test doesn't have one or two of just this type of related rate. So. Makes it slightly more important than the others. Of course, click the Get Help if you miss one, but if you're not sure why you missed it when you compare your work to theirs, then that's where I think let me know so I can help.
Replacing older senior laptops, and that's the fastest way they can get them to come down to the tech office.
Oh.
To report them stolen. So I got a new phone.
Oh, I don't know about it. That feels weird.
It worked.
I mean, yeah, it did, but
Hopefully it was charged.
Is this like your cover?
No, I mean, this is the one I can use in my work.
Oh, really?
You needed a replacement?
No, so you know how the seniors get the opportunity to buy their Chromebooks at the end of the year?
Yeah.
They give them the oldest Chromebooks. So then the oldest Chromebooks leave the school and they can get new ones. So this one's from 2019, which I'm so excited about.
But it's different than the one you had?
Yeah, because I had a newer one.
I thought part of the point was like to encourage y'all to take care of it and keep it running well so that if you bought it, you would have a nice one.
You'd think so.
Yeah.
Apparently not.
Well, I do know one of my advisory students from a couple years ago, her Chromebook broke like 2 weeks before graduation, and so then she ended up getting a brand new one on her way out.
Nice.
Yeah. Trying to put the scores in as I see some of you guys finish them up. Again, take as long as you need to on it. So it's fine if you need to practice it a few times, but this is important enough that it warrants the practice. But for those of you that finish, again, please just move on to the test review. You don't have to have the test review done by next class, but obviously the more of it you get done now means the less you'll have to worry about later. And that test review is structured kind of like the last one, where it reminds you of a topic like implicit differentiation and gives you a couple practice questions to help you see if you really learned what you needed to from it. Then it reminds you we also did related rates, and it's got 2 or 3 of those, just as a quick little snapshot of how prepared you are on those. Talks about derivative of exponential functions like we talked about this morning. There's a couple of those, and then I think there's one practice FRQ. So, and then the whole back page is all just the solutions to check. So that's not meant to be comprehensive, but it should help you identify which question types are going to be deserving of more attention between now and our third test. Hello? Okay, I'll let him know. Oliver, you checked out. That's what they said. Do you know where the purple office is? Okay. I don't know. You might need to call your mom or something to see what it is. I have no idea. again, while you guys wait for everyone else to finish the Khan Academy, just start chipping away at the test review. When all the Khan Academies are done, I will interrupt and give you a chance to ask questions from the big related rates worksheet we've looked at a few class periods.
Yeah, this right here. This is minus xy. So when you took the derivative of the xy with the product rule, it's still minus the whole thing. So you either need parentheses or you need to distribute to all the parentheses.
So it's like
Would this be like the same answer as, or sorry, this be the same answer as like the answer? Do I, like, how did it become?
See, yours are opposite, but these are opposite too. So like if you imagine factoring out a negative here, it switches both of those signs. And if you factored the negative out of here, it switches both of those signs. And then the negatives could cancel and reduce, and it would look that way.
Okay, cool.
So this is equivalent. So that's perfectly fine for an FRQ, but you would need to make sure that you know how to get from here to here if you had to for multiple choice.
Cool.
Basically, just multiplying everything by -1
Okay.
is all they did. Yes, sir. Mr. Johnson.
This would be acceptable on a test, right? Like if it was the FRQ?
Assuming that's equivalent, yes, I don't know. Oh, where's,
Number 1.
so you could divide out the 6's, yeah, so it's equivalent, so that's fine.
And on this one, I know that I think this is wrong. But I'm not exactly sure why.
Okay, that looks right.
Then product rule.
Product rule, derivative of x with y left alone, and the derivative of y with x left alone.
But I don't think that
You don't need-
chain rule says you do, right?
You don't need 2 y primes,
Why not?
because you're only taking the derivative of y once.
Okay.
So this one, we're on the same page. You took the derivative of x and left y alone. And then over here you left x alone, and then you took the derivative of y. Well, the derivative of y is just 1 y prime, but you have 2 y primes.
Okay. That makes sense. Like I knew it was wrong, but I
and then
wasn't too
just
sure.
dividing it by 2.
Yes, dividing it, you remember like you say when you divide fractions? Yeah, so like you're dividing it by 2 lines, so you can just pretend that's a fraction, so you flip it. So you're basically multiplying the bottom by 2 lines. Look at my work. I don't think it's gonna help at all.
I was gonna go I'm like almost done.
The blue ones are supposed to be harder.
Have you done 9 on there?
And they break a lot easier. Like I think I have 2 broken, that's all.
Okay, so yeah, I'm that far also.
You know, some bridge somewhere.
That happens in red one. Oh, it is. It's also the Saturn. The Saturn is bouncing around on the side.
I'll try to replace this.
So then everything will have the left.
And the
Oh.
Yeah, I whole punched it wrong.
And then we're gonna see like.
Okay, just a few more minutes and we are going to move on as a group. If you have not finished your Khan Academy yet though, you should stick with that. 'Cause that one should be due by the end of this class. You should definitely be finished with that.
Is there chain roll in there?
Instead of having any R's.
Number 3.
Or number 4. I guess at the beginning we could just do -5
Okay, here's the same.
If you do, what is your answer? 3x squared.
Yeah, so minus y over x minus 3y squared.
You know concepts?
Okay, so you know how like in complex fractions, we multiply everything by the smaller denominator?
Yes.
Okay, so as long as we multiply everything by the same thing, it's going to stay equivalent. So if you were to multiply everything by a -1 every term, I think, well, this ends up being positive, and I think they put that first maybe.
Yes,
Okay.
they did.
And then when you multiply this by a negative, it switches it. And then are these flipped?
Yeah, they're flipped.
Yeah, but when you multiply by a negative, then it's,
Was your y prime?
so yours is exactly equal. You just didn't simplify it the same way they did.
Okay, and then like on the test, is it gonna be like shown that way? Like would my answer be right?
As a free response, this is 100% fine. This is equivalent. On multiple choice, it just depends on whoever made the question how to simplify it.
Okay, thank you.
The other way you can think of this is just factoring out a negative and then factor out a negative and then like a negative scale.
I don't know if we need to ask electrical, I believe.
That's what I thought, it was too late to check.
I don't think natural logs are gonna help you with this. Yeah. Logs are good if you're like, yeah, it's more for like kind of curiosity.
If you're trying to like solve for something that's an exponent, taking the natural log of both sides is helpful because then this becomes an exponent on something you're taking the log of. So that's the only algebraic way to get it out of the exponent and let you solve it the normal way.
But what if you wanted to just like get around the, like, I guess,
No, so like,
some long amount of,
once you're here, that's great.
some big
So
fraction.
then you're
yes, like,
dividing
yeah.
it by 2y.
That doesn't, that's not gonna work that way.
Yeah, so you're just.
Like if you want to take the derivative of this,
So then whenever
you're gonna either have to rewrite it
yes,
or
it
use
is.
quotient rule.
the x's should.
Just because of the direction of
How do you start?
integration, or derivatives. Now, next semester, when we do integration, and it's the opposite of derivatives, you're gonna be going this way, so in that case, we might use natural log, because the derivative of this would be 1 over x. But that's only when you're going this way, and that's not until next semester, so that doesn't work for derivatives.
It's the only, since S is like the only term, if you like substitute
Yeah, but then
this
the
for
terms
the
cancel, so
R,
that should.
do I not need to
Because it's
specify?
like all water.
I think they consider S prime as fine.
And the answer is just say without any.
Two
I wouldn't have S prime
y.
either.
It doesn't matter. Okay, so let's see.
And then, yeah.
I
And
got
that's the answer, so it's 1 over
million. 165,635. So
Yeah.
We've got S prime right here. I don't know that I don't agree with this part. This shouldn't be so S. The derivative of 4S.
yeah, this is. I'm sorry.
You don't want
This is
any
mine.
R's, so
Would it
this
be
is equal to R, plug this in for R.
This is me taking the derivative. So this is just me rewriting the equation
Okay.
and plugging
Gotcha.
this number in.
Okay. You can do that later though.
Okay.
No.
So should I?
It's like
It's up to
4s minus 5
I would just take the derivative of this with respect to s, and then everywhere there's an r, replace it with that.
So taking the derivative with respect to s, does that mean I'll only have the r prime?
Correct. When you take the derivative of s with respect to s, you get ds over ds, but that's like minus, we don't do that. That's why the derivative of this just becomes 4, not 4s prime. I think that'll work out. Try it and see.
So, I got this as my answer, but how do I know to multiply this to this and not to like the 4? Is it because it's like the chain rule, so it's like out of very
I think it's just order of operations. It looks like you have 4 minus
Oh, you're right,
times
you're right.
something.
Yeah.
So you would only multiply these two.
No, that makes sense.
Okay, I am going to steal your attention here for just a second. So, I would like us to kind of branch in 2 different paths here. As I had mentioned, I want to be finished, as much as I like these question types, I want to be finished with handout 41, because this will be the 3rd class. I give you time to work on it and ask questions and such. So, you need to find that in your binder, see which questions you were not able to figure out. Again, I did ask you to use the class videos on the website to try to narrow that down at least, but I know that's not enough sometimes. So you need to see which ones you need to ask to be finished with that, and of course there's going to be some people asking some questions that don't apply to you. So you can either choose to follow along if you think it'll help, or you can tune us out for a minute and work another question or 2 from your test paper. That way you're doing something productive either way. So walking around the classroom, I feel like 1 through 6, you guys had time to get individual help with me on that one. And then what about from page 2? Questions 1 through 4? Any of those you would like me to go over? Number 3? Sure. Okay, so if you need help with 3, pay attention to me. If not, work quietly on your review alone for just a second. Okay, so before I even read 3, I do know what this one is because so many people asked about it before, but again, the most important thing with these related rates is you have to have the process memorized. You can't be fumbling around thinking about what am I supposed to do next. You need to try to make a picture most of the time. You need to try to define your variables or label your picture with links and speeds and stuff like that. I know I'm going to have to come up with a geometry formula. I know I'm going to have to take the derivative of the geometry formula with respect to time. And then best case scenario is I plug in those links and those numbers and solve for what I want. Worst case is sometimes we have to dig deeper to find another length or 2. So in question 3, you absolutely needed a picture. A person 2 feet tall or 2 meters tall is walking away from a street lamp that is 8 feet tall. And so this light source is going to hit the top of this person's head and then create their shadow. So here's the shadow on the ground. If the person is walking at a constant rate and the person's shadow, so this speed is 4/9 of a meter per second. At what rate in meters per second is the person walking? Well, if this is where my person is, I'm trying to figure out his speed, so I want to know how many meters per second he's walking. So, simply by knowing these 2 links and knowing how fast the shadow is growing, I can figure out how fast this person's walking. Now, for this question, to come up with the geometry formula, it's a little bit different in that it's not just area of a circle, Pythagorean theorem. It's not really a formula per se. But on this, if we call this length x and this length y, I don't know this length and I don't know this length. The geometry formula they're expecting you to pull together for this is a proportion. So anytime you have a smaller triangle inside of a bigger triangle like this, it guarantees that these are similar triangles. And similar triangles are not the same size, but they are the same shape, and that guarantees that the sides are proportional. So I could pair up 2/8. So I took small triangle length compared to big triangle length, and then I need to be consistent with that over here. Small triangle length is x, big triangle length is x plus y. So that's a proportion, a very popular type of proportion that you should have seen in geometry. It sounds like you guys maybe didn't do that one very much. But occasionally they do expect you to make that proportion. Then if you were to cross multiply, combine some like terms, basically just simplify it a little bit, but we knew at some point we were going to need to take the derivative. So the derivative of y with respect to t, the derivative of 3x with respect to t. They gave me that x prime is 4/9, and they wanted me to find y prime, so that would end up being 4/3. Should be D. Okay, so I went through the last part pretty quickly, but again, all I did was simplified a little bit, took the derivative with respect to time, plugged in the thing I knew, and solved for the thing that they wanted. Is there something more specific about that one? Anthony, that's yours.
No, okay.
That's okay. Okay. Anybody else that's going to ask about 3 need to ask this one? Something more specific? Okay. Last thing I'll say about this one is, again, it's fine if you don't remember, or it's not your fault if your geometry teacher didn't make you practice setting up these proportions a lot. But it sometimes does show up on the AP exam. This is an released AP exam question. So I honestly don't know if we have that on our next test. I don't know if it's going to be on your AP exam next year. But that's the type of stuff that you guys should put a star by and make sure that you remember that if you have this type of picture, you could set up this type of proportion. That's the type of thing you should review before the test in case that type of question's on the test. I think if you get to here, you'll be fine. Okay, others on this page, which would be 1 through 4. Number 4. Okay, if you did not need help with the last one, make sure that you don't need help with number 4 before moving on your own pace here. All right, we've got a 25-foot ladder sliding down a vertical wall. And he's moving, the ladder is moving down at 3 feet per minute. Now notice, because it's going down, I did make this length negative, or the distance negative, to indicate that direction. When the top of the ladder is 7 feet from the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? So how many feet per minute would that be? Okay, so based on my picture, I'm guessing this is a right triangle type of question, so most of the time that's going to be Pythagorean theorem. Take the derivative with respect to time, so that's going to create a prime, a b prime, and a c prime. If you want to divide everything by 2, you can. It's optional. And then we can start plugging in some of our information. So one of your legs needs to be called A, one of your legs needs to be called B, the hypotenuse has to be C. So A, I know, is 7 feet, and A prime is negative 3 feet per minute. B, I don't know his length. B prime is how fast that's changing, and that's the whole point of this question. So that'll be the last domino to fall. I know the length of C, and I also know the rate of change of C. This is not changing at all. The 25-foot ladder is always going to be 25 feet. So the rate of change of C has to be 0. Okay, you okay with all those parts? Okay. So as I said, every one of these questions, usually a picture helps, usually labeling your stuff helps. At some point you got to come up with the geometry formula. At some point you have to take the derivative with respect to time. And then the question can branch in one of two ways. You plug in the information you have, you solve for what you don't have, and you're done. Or in this case, there's still one more piece of information you need before you can solve for what they're asking for. So this is where you have to dig a little bit deeper, but notice in my right triangle, I know this length and I know this length. So Pythagorean theorem or Pythagorean triples could tell us this length is 24, I believe. Is 7, 24, 25? Okay. So you've got to do Pythagorean theorem out on the side just to figure out this length has to be 24 feet when this is 25 and this is 7. So now we can go and make this change. And then the rest of the question should be some algebra. This is -21 added over. This was 0. Divide both sides by 24. Start looking at the answer choices. None of them look like that, but that's because you could reduce. You could divide this one by 3 and this one by 3, and then that should give you choice D. I did the Khan Academy that you guys did this morning with my 8A class, like, I don't know, it feels like Wednesday of last week. Maybe it was Friday, but a lot of those were similar to this, weren't they? They were? Okay. Because they love to ask these question types, especially these ladder on-the-wall type questions. So, a good one to catch. I would say one thing about this that is easy to make a mistake on is I could totally understand where you came up with -7/8. If you had thought this 3 was positive, because it's a positive 3 here, but this word made a big difference. It was going down 3 feet per minute, and that's why I made it not 3 feet per minute, but -3 feet per minute, because it was going down. That's very easy to just plug in a 3 there, but it should be -3. Okay, if I'm moving on from this page too quickly, that is okay. I'll give one more chance in a minute. But the next page had questions 5, 6, 7, 8, and 9. Okay, Julia?
Can you do number 6?
Do we have to? Did anyone finish number 6 and feel pretty confident about it? You got the right answer? The answers are on the bottom of the back page.
Oh.
The answer to that one should be 32.
Oh yeah, I got it right.
Good job. All right, number 6. I don't know, this is just my theory. In front of me. But every year I rework these, and number 6 is always one that I kind of have to pause and reread a couple of times. It's a little bit trickier. It's definitely a longer question. We don't really know when or why they choose to release the questions that they do, but this one particularly seems like excessively hard. So I suspect that whatever year this one came out, probably the average on that question was so low that they didn't ever want to use it again. So that's why they went ahead and released it. Okay, but one thing that makes this question hard is or at least to me, you might disagree, but the fact that they use P, Q, and R bothers me a lot because that's really hard for my brain to compute. So R is always the side opposite angle R, P is always opposite the angle P, and Q is opposite angle Q. But for my sanity, I went out to the side and said, I'm just going to refer to this as C, and then I went ahead and called this side A and this side B. So even though the question did P, Q, and R, I put A, B's, and C's on there. So every time they say R, I'm going to say C. Every time they say Q, I'm going to say B. And every time they say P, I'm going to say A. Because to me, that's easier. Okay, so I can quickly tell that... Okay, it says we've got a 40-foot ladder against the wall. The ladder is slipping down the wall. So there was a little arrow there to kind of show that. What is the distance RQ? So this would be A. What I'm calling A is RQ. At the instant when Q is moving along the wall, along the ground, 3/4 as fast as P is moving down the wall. Okay, well, if we're talking about side lengths and the rate of change of side lengths, my best guess is that this is probably Pythagorean theorem. Of course, everything we're doing this semester, except for a couple weeks of limits, is derivatives, so there's really no surprise that we need to take the derivative somewhere. I immediately know that C is 60, and what about the rate of change of C? Right, it's a ladder, we're assuming that it's not changing lengths. I never really thought about that, but ladders often do change lengths, right? Like they extend or contract or whatever, so I don't know that they should be doing that, but and then you realize you don't know length A, you don't know length B, you don't know the rate of change of A, you don't know the rate of change of B. So this question just requires you to dig in quite a bit deeper here. But that last sentence, and this is the, and maybe it's just me, but the last sentence we need to translate into a math statement. The one that says, when Q is moving along the wall, or along the ground, 3/4 as fast as P is moving down the wall. So the rate of change of Q, if I multiplied it by 3/4, it would be the same as the rate of change of P. But I think maybe what's hard for me is it says it's moving down the wall, so that's negative. To me, that's what that last sentence is trying to say. And this is probably the hardest part. The rate of change of Q is 3/4 as fast as the rate of change of P moving down the wall. And I just moved the negative over. Now I'm trying to use A, B's, and C's. So instead of saying Q, I'm going to replace this with B. Instead of Q prime, I'm going to say B prime. Instead of P prime, I'm going to say A prime. Now, how this can be useful... Sorry? This is okay? Okay, so you don't see how this is going to be useful, but now we can take this and we can go and substitute it in up here. So instead of saying A prime, I put what A prime is equal to, negative 3/4 B prime. And that doesn't immediately look helpful, but now this term has a B prime and this term has a B prime. So if both terms have a B prime, I can factor out that GCF. And to me, this is pretty easy to see how to move forward here, but you guys aren't used to seeing it this way. But you know, when you do stuff like this in algebra, if this times this equals 0, either this could equal 0 or this could equal 0, right? You've done that hundreds of times. Well, same thing with this. I've got something times something equals 0. So I can set B prime equal to 0, and I can set this equal to 0. Now, for this question, this one doesn't make sense. This is saying one possibility is that B prime doesn't change lengths, but we know in the context of this question, the ladder's falling down, so this rate of change is not staying the same. But over here, this is kind of nice because now I know B is equal to 3/4 of an A. Once again, not obvious what you should do with that. But if I reset one more time and say, let me look at Pythagorean theorem again, but instead of saying B, I'm going to say 3/4 of an A, because I now know this relationship. I've got 1a² plus 9/16 a². So if you get a common denominator here, this is like 25/16 a². And I've really known the length of C the whole time. That's the ladder, not C prime, but C. And then to finish, if you multiply both sides by 16, divide both sides by 25, and take the square root, you end up with 32. So it was the fact that they gave you less numbers to work with and instead gave you this relationship. But that last sentence, translate that to a statement, plug it into your derivative that allows you to solve for B in terms of A. And then once you know what B is in terms of A, you can redo Pythagorean theorem, leave A the same, write B in terms of A, plug in the number that you know C is, and then you're left with an equation that only has A's, which allows you to solve for A. And A for me was the P that they were looking for. Yeah, the distance RQ, which is what I called A. So that's why I suggested to you guys to save that one for the end, because this is one that you could feel good about all the other questions and still feel kind of shaky on this one, because that's usually where I am each year. But is there part of that you'd like to discuss again, the general idea? The other issue I think that with this being on the actual AP exam is, I've mentioned the timing to you guys before, but typically you either get 2 minutes on average or 3 minutes on average. Calculator questions are 3 minutes on average, but not all questions on the calculator part need a calculator. Some questions a calculator just doesn't help, so they put it on the calculator part. But non-calculator questions, which is what I would expect this to be, because I didn't really need a calculator for this, really only have an average of 2 minutes. And you can know related rates really well. I don't think anyone's going to do this in 2 minutes. And it's fine that some questions can take more because it's just an average, but I suspect that the score on this one was just so low the year it was given that they didn't want to put it on any more AP tests. So that's why they released it. Okay. Others from this page, so that would be 5, 7, 8, or 9. Yeah.
Could you go over 8, please?
Number 8. Okay, if you were good with the last one, please make sure that you're okay with 8 before you continue to tune me out here. So this one gives us a picture. It tells me theta is increasing at a rate of 3 radians per minute. It wants to know what the rate x is increasing, so that would be x prime, at the instant when x is 3 units. So they gave me the picture, I defined the variables. Probably the biggest hurdle on this question is trying to come up with a geometry formula. Now, you're more than welcome to start off with Pythagorean theorem, but the problem with Pythagorean theorem is you're never going to have enough information to solve for what you want. Partly because Pythagorean theorem is never going to let you include the rate of change of theta. So makes sense to think it's going to be that because that's the most common type of related rate, but this one's not Pythagorean theorem. There's another way to make an equation that includes the angle, his opposite side, and the hypotenuse, and that is with a SOHCAHTOA equation. You could say sine of that angle is equal to opposite over hypotenuse. This is the geometry formula that they're referring to. This is the thing we should take the derivative of. You can see this isn't super common, but even that card sort we did the other day had two of them like this. Two where the geometry formula was a Pythagorean theorem. So now we need to take the derivative. So the derivative of sine something would be cosine something, but I just took the derivative of theta with respect to time, so I need a theta prime, which is not a problem because I know how big that is anyway. And then this one worries me a little bit sometimes, that y'all don't do this a little bit quicker. If the derivative of 3x is 3 and the derivative of 5x is 5, the derivative of 1/5 x is 1/5. X over 5 is the same thing as 1/5 x. So this would be 1/5, except I'm taking the derivative of x with respect to time. You have to do that every single time. Remembering it once is not enough. Every single variable, unless you're taking the derivative of t, you need a prime. Theta prime, an x prime, a y prime, whatever. And then if you get to this point, I think you're probably in pretty good shape because theta prime is given to you. X, it doesn't look like I need that, but I don't know the cosine of theta. I know x prime is what I'm trying to find, so that will be the last domino to fall. So I still need to find cosine theta. Well, how do we normally find cosine of an angle? Okay, so you got to solve for adjacent. It would be 4. So cosine of that angle would be 4/5 because it is adjacent to his hypotenuse. Multiply both sides by 5 and you end up with x prime is 12. So choice E. So I would say probably the most common mistake on this one is some of you guys may not have thought of trying to make a geometry formula from a SOHCAHTOA equation, but that's needed sometimes. So that's the type of thing you should mark up on your sheet, so when it comes close to our test time and you're reviewing, you can look back at that and say, oh yeah, I need to consider SOHCAHTOA equations sometimes. If Pythagorean theorem's not working, it might be SOHCAHTOA. SOHCAHTOA is also for right triangles. Okay. Harper, was that yours?
Yes.
Okay, is that enough?
Yes.
Okay. Anybody else that was going to ask about 8 have something more specific while it's up? Okay, then any of the others on this page, that would be 5, 7, or 9. Julia? Number 9. Okay, the base of a triangle is increasing at a rate of 3 inches per minute. So that would be B prime. The height is decreasing at a rate of 3 inches per minute. What must be true about the area of the triangle? Okay, well, what is the mistake that I breezed past in here?
There should be a negative.
Right, if it's, this is increasing, so this guy was positive, this guy was decreasing, so he needs to be negative. Yeah, I know it's a triangle. So base and height, and I want to know something about area. So we're talking about triangles, and it wants to know something about area. My guess would be the area of a triangle formula, 1/2 base times height. If I want to know how the area is changing, increasing, decreasing, all that kind of stuff, I care about A prime, his rate. And to take the derivative of BH, you're going to have to use product rule. The derivative of B with H left alone and then the derivative of h would be left alone. This is with related rates are always with respect to time, so that's why I needed a b prime when I took the derivative of b and an h prime when I took the derivative of h. And if I start plugging in this stuff, I know this is 3. I know this is -3. And they're asking of something about how the area is changing. So it's going to be increasing if the derivative is positive, and if the derivative of a is negative, the area is decreasing. So unfortunately from here we kind of just have to reason through the rest of this. I would like to know when this is positive, when is the rate of change of area positive? And so I start thinking about this. 1/2 is always 1/2, and a positive times a positive is going to be positive. So here, I guess I could factor out the 3 too. That might make it a little easier to see. But what you ultimately need to have to investigate is that this guy's going to be positive only if his height is bigger than his base. Because if this number is bigger than this number, it's going to be decreasing. But if h is bigger than the base, then the rate of change would be positive. So another way to say that is to say if b was bigger than h, this would be negative. So the rate of change of area would be negative. So it is going to be decreasing area if b is bigger than h, which is choice D. That last part, again, you can't really just solve the last couple steps algebraically. You have to think about what's going to make it bigger than 0 or less than 0. Less than 0 is when it's decreasing, greater than 0 is when it's increasing. But for this to be positive, h has to be bigger than b. For it to be negative, b has to be bigger than h. Okay, let's move on. And again, I will give one more chance for any page after the last page. Last page only has questions 10 and 11. Either one of those two that seemed harder than the others. Yeah, Frankie.
Can you do 11?
Okay. Okay, 11 says when x equals 8, the rate at which this increases. Now what does that sound like they want you to do with this? Right, rate is derivative, so I'm going to say this is, there's his derivative, so this represents his rate. So they're saying the rate at which the cube root of x increases is means equals 1/k times the rate at which x is increasing. And what's the variable for that?
X prime.
Okay, and actually I do have one mistake in here.
Should it be
And it was something I lectured y'all on like 5 minutes ago.
x prime over 3x 2/3?
Yeah, right here. This isn't really the derivative. This is the derivative if I was taking it with respect to x, but I was taking it with respect to t, so I should have put an x prime there too. Well, I really only need to know when this happens, when x equals 8. So let's plug in an 8 here. Both sides of this equation have an x prime, so let's just divide both sides by x prime. That goes away. Both of these have a numerator that's already 1, so if I want these to be equal, I really just need the denominators to be equal. But how do I go about taking 8 to the 2/3 without a calculator? Okay, we could do 8 squared, which would be 64, and then we could do the cube root of that. What's the Cube root of 64 is 4. Or you could do this in the other order. You could do the cube root of 8, which is, and then you could square it, which gives you 4. To me, that's a little bit easier to do in my head, but both are perfectly fine. So k would have to be 12 for those to be the same. So rate of change of this means derivative. Is means equal. 1 over k times the rate of change of x. So 1 over k times x prime. Plug in 8 for x. And then solve for k. The x prime's canceled out. This isn't too bad. And I'm pretty sure that was a no calculator question. It was. So this is, I don't do this, but a lot of calculus teachers do this, so you guys will probably see this on worksheets in the future. Do you notice on the answers how 2 of these have little asterisks by them? Those asterisks are a way for you to know those were on a calculator portion. So 1 through 11, all of those were no calculator except for 9 or 10. And if you look at 9 and 10, 10, calculator's not going to do anything for you. 9, calculator's not going to do anything for you. So just because they're on the calculator part doesn't mean you need a calculator. Or that a calculator even helps. But okay, so I promised one more time, in case I had moved on too quickly, any of these questions from any other page. Any page.
Did you do number 5 on page 2?
5 on page 3?
Yeah.
Yes, I will. Okay, it says the radius of a circle is increasing at a non-zero rate. So the rate of change is not 0. The rate of increase in the area of a circle, rate of change of area, is numerically equal to the rate of change of its circumference. So C prime. At this instant, the radius equals what? Okay, well, they're telling me that the rate of change of area is equal to the rate of change of circumference. So I'm going to have to think about the area of a circle formula so that I could take his derivative. You have to know the circumference of the circle formula so you can take his derivative. Make sure you don't forget the r primes there. And then if these are supposed to be numerically equal, you could set this one equal to this one. And we're supposed to solve this for r, which actually works out pretty nicely, because if you divide both sides by a 2, a pi, and an r prime, you're left with an r equals, and over here you've got something divided by itself, so 1. But this is another great example of how every one of these questions has a different feel to them. But geometry formulas, take the derivative with respect to time. That part will be consistent. Okay. Was there anything else there, Cooper? All right. So if you are still not finished, I guess at this point you are on your own to finish that one. Again, I think I have all of the back to page 2, page 3, page 4. I think all of those are worked out as videos on the website, except for question 4, but you guys asked that one today, so shouldn't need help with that one. But I will be asking for that one at some point. It'll probably be a 20-point homework assignment instead of a 10, because I know it took more work, so I tried to do that sometimes. So make sure that you have that finished. And again, you do not have to have the test review finished when I see you guys on Tuesday, but the sooner you practice those questions, the sooner you realize what it is you're going to need help with. So you're certainly encouraged to work on it if you have time. but your only homework will be to finish up 41 if it's not finished.